Welcome to a STEM Life demonstration brought to you by
STEMmy Sam.
STEM Sid.
Hello, STEM students. Welcome to a STEM Life demonstration. And for this demonstration, we are going to need the following: a glass of hot water, a glass of room temperature water, and a glass of cold water, also known as H2O. Now, all three of these jars have the same amount of H2O. And then what we're going to need is we are going to need some green food coloring. Now, in this experiment, we are going to be testing the question, how does the temperature of water affect the rate at which the food coloring is able to completely disperse throughout the water? Now, in this video, I want you to go ahead and click stop so that way you can identify the variables of this experiment as well as your hypothesis for this experiment. Alright, Stellar STEM students, now let's go ahead, let's conduct this quick STEM Life experiment and see if your hypothesis was correct. So what I'm going to do is I'm going to go ahead, I'm going to take this green food coloring and I'm going to drop it in all three of these containers. Just 2 drops, maybe 3 in each container, but it will be the same amount of food coloring. So here we go. First in the cold, 2 drops, 2 drops, and 2 drops in the hot. So let's go ahead and observe. Which one is having the food coloring spread the fastest? Alright, Stellar STEM students. Now, I'm going to turn it over to my fellow STEM instructor in order to explain how this experiment happened.
Alright, so what we ended up having here when we're investigating how does the temperature of H2O affect the rate at which the food coloring dissolves, we first have our independent variable up here, which is our temperature, as well as we end up having our dependent variable down here, which is going to be our measured variable. Now, we have several controlled variables. One of them could have been the amount of liquid in each container. Another one could have been the type of container. We're all the same. As well as we could have had the amount of food coloring that was dropped into each container was about the same, which was about 2 drops. Now, when we looked at this, we saw that the hot H2O was able to disperse the food coloring faster than both the room temperature and the cold water H2O. The reason for this is going to be due to something known as molecular motion. In the cold water, we're going to have molecules that are closer together that aren't moving as quickly. In the room temperature water, they're going to be a little bit more spread apart and they're going to be moving faster, which is why I'm drawing those longer arrows there. And then in our hot H2O, they're going to be spread apart even farther and they're going to be moving even faster, which then carries the food coloring around faster than both the room temperature and the cold H2O. So, thanks again for watching. Make sure that you fill out the reflection at the bottom of this Google Form assignment. And thank you for watching another STEM Life demonstration.